Hello guys, welcome to another video. In the previous video we have seen about DAGs and little bit of tasks also. In this video we will see more things which we can do with the task, like what are all the techniques which we can apply to the tasks. Okay, just to recall what we have seen in the previous video, we have seen how to create the DAGs using with as well as with the decorator. We have seen how to create the DAGs in two ways, and then inside which we know we create the task. Even the task can be done using two ways. One is using the operator directly like this, and the second thing is using the decorator, which we have seen. And the hierarchy of the task can be created using the greater than, like first run these tasks, then these tasks, or else if you have like more than 10 15 something like that, we can add all them as an arguments inside this chain method. And we have another method called cross downstream, which we can use it. So what happens here is, once this set of tasks are done, execute these tasks parallelly, something like that. If you want, instead of sequentially you want something to run parallelly, then you can use cross downstream. So these are the techniques which we have seen in the previous video. So now let's check few other techniques which we can apply in the task. The first thing is airflow fail exception. So in case if you want to specifically fail a specific task in a DAG when a condition is not satisfied, then you can use this class airflow fail exception. So it will raise this exception and it will fail the task. So what we are doing here, I'm just creating a DAG using with and schedule daily. That's it. I'm creating a Python operator task. That's it. And now inside the Python operator, I'm calling this particular method. That's it. So in this method, we are, when our condition is not satisfied, we are just raising an exception. So now let's go here. Let's execute that particular method. If you see here, so this is a DAG fail example. And when we trigger this, we are explicitly failing it. If you see here, we are making it as false, and if it is false, please raise an exception. If you see, it has failed. We are raising an exception. So when we go to logs, we can see it has raised this particular exception which we have thrown. So when a specific condition is not satisfied, and if you want to specifically fail a task, then we can go with this kind of approach. And the next thing is airflow skip exception. So instead of failing, in case if you want to skip a specific task, then you can use this particular airflow skip exception class. We can raise this exception. So what happens here is, instead of task getting failed, the task gets skipped here. So when its task gets skipped, the next set of tasks will also get skipped, right? All the downstream tasks will also get skipped. So we have already seen how to handle these kind of scenarios in the previous video. If you have not watched my previous video, I recommend to watch this. So where I have introduced about what is trigger rules. So let's assume this particular task has been skipped because it has not satisfied our condition and it has skipped. So these two also get skipped. We don't want that. We want to execute these two. So then what we can do is we can apply the trigger rule. So what we can do in the trigger rule is trigger rule equal to trigger rule dot all done. So what is all done? Whether it is skipped, failed, success, anything doesn't matter. Please do execute this particular task. So once this particular task is executed, the next downstream will also execute by default. So this is how we can handle or manipulate when a specific task has been skipped. So if you want more details, you can watch my previous video. I very clearly explained all the trigger rules. One success means if any of the above task is successful, any one, then please do execute this. If all above are failed, then execute this. That's what this all fail means. If any of the above task has given output as failed, success, skipped, or anything, doesn't matter, please do execute like that. That's what all done means. So I've explained all the trigger rules in the previous video, which is about while I was explaining the DAGs. Please do watch that. And that's it. So now let's go and see the example of airflow skip exception. Okay, what is the DAG name? Skip example. So now if I come to skip example, and if I trigger this specific DAG, this particular task gets skipped because we are by default handling it. We are marking it as false, and if it is false, please skip it. See, it got skipped, and if we check the logs, this particular task gets skipped without any error, but the previous DAG which we have seen as failed. Okay, and the next thing is execution timeout. So for suppose if you want a specific task to run only a specific interval, you don't want it to run like hours and hours, you want it to run only a specific time period, then you can go with the execution timeout. So here if you see, I'm just mentioning, please do make sure it doesn't run more than 60 seconds. That's what I meant. But if you see my bash command, I'm sleeping it for 120, and then with this I'm just checking, please make sure this particular task will not cross more than 60. If it crosses more than 60, then it will throw an error. That's what will happen. If you see, what is the DAG name? Execution timeout example. So now if we come here, execution timeout example. This should fail because I'm sleeping for 120 minutes. So the task will run for I'm sleeping for 120 seconds. The task will run for 120 seconds. But here I'm just checking, please throw an error or an exception in case if this particular task runs more than 60 seconds. So it should fail. So let me trigger this. See, it will be checking for 60 seconds now. And once the 60 seconds is done, it will throw an error. If you see guys, it has come to up for retry because when a specific thing has failed, it will retry 3 times, right? By default in the default arguments, even if you don't pass, it tries 3 times retry. So that's why it has come for retry. And then after 3 times retry, it will fail. I'll show you that. Meanwhile, we can go and look into another example. See what is hooks. So we know like pre and post hooks, it's there in almost every application, right? So what is pre and post hooks here? So in case if you want to execute a specific method or some logic to be executed before the execution of a task or after the execution of a task or before the execution of the DAG or after the execution of a DAG, or if a task has been failed, then you want a custom method to be executed. Those places we can go with the hooks. So what happens is I've just created a DAG as it is. I have added these two also. I'll come here, but if you see, this is my first task. I have done nothing here. But here, if you see, I have added 3 particular extra arguments: on execution callback, on success callback, on failure callback. So what does this on execute callback? So once this has executed this particular operator or a task, then this particular method gets triggered, pre-task. This particular method gets triggered and we are just printing here the task ID and the execution date. That's it. So, and then once this particular has been successful, immediately after executing, this particular method gets called. Once this is completely successful, then this particular method gets called. In case if this specific task has been failed, then this particular method gets called. So that is how the hooks gets handled here. And similarly on the DAG level, we can apply here on success callback. Once the DAG has been successful, this one, once the DAG has been failed, this particular method please do call. Here we are just logging, we'll see that. If you see here, on execute callback doesn't exist in the DAG level, but on execute callback do exist in the task level. So we can't do this. So now let's go and see the previous example. It is still in retry. So it will go in the fail state. So this is how the hooks work. So let me go and trigger this particular hooks example also. If what is the name of this particular DAG? Example pre-hook, post-hook task. So this first one. So when I come here and when I execute this, if you see, we are just doing echo here, echo here. So now we have come here. This is successful. So now if we see the logs, see, hello Praveen Reddy C has been executed. This is what has happened. Now what we are saying, on execute pre-task, post-task, right? So all this comes under here, post-task execution and pre-task execution. So what am I doing in the pre-task? What am I doing? I'm just printing pre-task hooked at the task ID, right? So that should be there inside the pre-task only, which is not there here because we are checking the first particular task. Here we are not calling those. We are calling the second task. So let's go to the second task and the logs. If you see, we have that particular log here. So before the execution of this particular task, we have the pre-task, and after the execution of this particular task, we have the post-task, which is what we are logging here also, the post-task hook. So that is how the pre and post hook, before the execution of specific task and after execution of specific task. In case if you want to see what you have called in the DAG level, we can't see here. These are on the task level logs. Airflow will always show you the task level logs. We here, when you click on the DAG, we'll just have the event logs, which we can't see clearly. So for that, you have to go to the scheduler.log file in case if you are running locally. In case if you are using AWS managed workflow, Apache Airflow, then you have to go to the CloudWatch logs. So let me show you once the CloudWatch logs as well. So if I go to CloudWatch, if you see, these are the log groups I have. So I have one for DAG processing. I mean, when you upload the DAG into S3, what are the logs it has generated? These are the scheduler logs. These are the task level logs. These logs only we are seeing in the Airflow as well. The same logs can be viewed again here. The scheduler logs can be viewed here. So like that we see. Okay. So we have seen it, but before we missed to see the execution timeout is failed or not. So if you see here execution timeout, if you see here it has failed previously because after a specific interval of time it has failed. Now if I go and check the logs, we should have the timeout. You can see Airflow task timeout, because that's what we are doing here. After 60 seconds, please do fail, because this task runs for 120 seconds. Like that, we have seen here. So the next important thing is Quarks. See, Quarks is very widely used, which we have also used in our project once. So like for many things, because it majorly has the DAG ID, run ID, and whenever you want to log specific information into your audit tables, we need a DAG ID and run ID, right? DAG name and also, which we get from the Quarks only. And also the execution date, when it has executed. See, when you are doing a backdated runs, let's assume you are running for the last 1 month DAGs today. So you need the specific days run. So if it was last month 12th, you need 12th. If it was last month 13th, you need the 12th date. Everything comes from the Quarks of execution date. Okay, let's see this. Okay, I have a simple DAG. That's it. Here I am just doing an extra thing called params name Praveen. Using Quarks, we can even access these kind of parameters also, params as well. So that's what I wanted to show. So this is my operator or a task, and then I have this particular method which we are calling here above. So in this in this method, I just tried to cover as many as the attributes which we can get from the Quarks. Okay, just logging everything. That's it. And we need to pass this. So because all this comes from the context, because from the Airflow context only we get all these details. So we have to just enable this particular parameter, provide context equal to true. Then only we can get all these details. Okay. So if you see, I'm just calling this particular methods and just take this default argument. And here, if you see Quarks of DAG, get the DAG ID, we can get run ID, the DAG run, the task instance, the execution date, on which date run is happening, DS, what is the date we get here, DS no dash means without that. Let's assume if today's date is 2025-0202. So instead of hyphen will not get, we'll get 2025-0202 instead of, but here when you use DS, we'll get 2025-02-02 like that. Previous days, next day's data, previous days no dash, next day's no dash, the timestamp no dash, the previous execution, next execution date, and these are the parameters. So if you see, we are passing the parameters here, and while triggering the DAG also, it will ask for the parameters. Here I by default passing the name Praveen. Okay, so here if you see, I am reading those particular Quarks. If you see Quarks.get of params, okay, we'll just print whatever we are passing here. Name Praveen will get printed here. So now if you see, if name in Quarks of param, if name exists, then print the specific value. If the key has name, then print the value is what we are doing. Then if you see, the Quarks has another method called macros, and using macros also we can, using Quarks of macros, we can get the current dates and we can add some dates. If you see here, I am subtracting minus date, current date minus 1. If you see here, I am adding 7 days to the current date. And here if you see, I am changing the format. To change the format of the date, we can use Quarks of macros.ds format. Okay, and the DS, the current dates format will be changed from this format to this particular format. If you want to add specific days to the current date, when you go to the real time, we do use this Quarks very widely for logging what we are doing inside the tasks. Okay, this is very highly used, which I have seen. So now let me go and trigger this particular DAG. So what is the DAG ID? Quarks. So let me go and trigger this DAG. So now if I come to Quarks here, and now if I execute this particular task gets triggered. Now before triggering task, as at the DAG level, we have passed this particular value, right? Here by default the Praveen has passed. So let me change it to Praveen Reddy C, and now we can trigger it. So the value should be Praveen Reddy C only here, this particular value for the key name. We did not change the key, we just kept the key as name only. So now it has executed. Now if you see, I'm just printing in this method, right? This is the method we are calling in this task. That's it. So now if I come here, we have the logs and everything gets printed. See the DAG run ID, the DAG run, the task ID, the execution date. If you see here, no dash without hyphen. Okay. See, I have passed Praveen Reddy C. I got Praveen Reddy C. So the value custom parameter here, custom param Praveen Reddy C. We have, see, yesterday's date, next week date, all this we can add, because if you see here we have added 7 dates, right? So next week exactly this time it's 9th. So like this, using the Quarks, we can fetch all the metadata information or the dates information majorly. Okay, that's the purpose of the Quarks. And we have another concept called SLA. And using SLA, if you see in the timeout, if a specific task has executed for a specific interval of time or more than a specific interval of time, we have failed that particular task, right? So instead of failing that particular task, in case if you want to send an email, then you have to go with the SLA. Or else in case if you want to send some warning, you want to update some kind of audit table, then you can go with the SLA. To use SLA, we have to use this particular parameter in the SLA miss callback. We are just calling this particular method, and here we are just logging this particular information. Okay. So now if you see here what is SLA I am giving? I am giving an SLA of 10 seconds. So if this particular task has been executed more than 10 seconds, then it will call this particular method and this gets logged. Same. It gets in the scheduler logs only similarly, and this is the same. So this is the purpose of SLA, and this is how, the major difference between the SLA and timeout is SLA will not throw an error. It will just send an email or update the table or whatever you want, but it will not throw an error. But the timeout will throw an error. And the final thing which we need to know is the timeout. We have already seen the execution timeout, and what is the timeout, which we again see in the sensor video. If you see here, I have just created a DAG, that's it, and I have a sensor here. See, and the difference between the sensors and operators is like sensor is ideally used for poking, like if a file has been arrived or not, if a trigger file has been arrived or not, those kind of scenarios we use the sensors. I'll more detailedly explain about sensors in the next videos. But here if you see, this is the class for in case if a specific file has been arrived or not. To check that, we have this particular class in S3. In case if we want to check in the local, we have to use file sensor and the file path. For S3 you have to use this particular, and I have the task ID, the bucket name, the path, AWS connection ID, and all those things we need to give. As right now my Airflow is running in MWAA only, which is AWS managed workflow Apache Airflow. That's why I just gave the default ID. Otherwise you have to give the connection ID, which you can get from the XCOM as well. Here if you see execution timeout and the timeout, see what is the difference between execution timeout and the timeout. Okay, so execution timeout, it checks for each and every poke. This particular file sensor, when it checks in the S3, it should check maximum of 20 seconds. In case if it doesn't get back the response from S3 in 20 seconds, then it will throw an error. But overall time period for this particular task is mentioned in the timeout. That's the major difference between the execution timeout and timeout. When you don't mention this execution timeout, then when you don't mention this particular timeout, this execution timeout only will work for the whole task in the operator world, not in the sensor world. If you see here, we have given for the whole task only. Here, the whole task should not exit more than 60 seconds. But here we are using it with the sensor, so it is deferred here. So execution timeout for the each poke and timeout for the overall particular sensor. So our system or our DAG or our task will wait maximum of 200 seconds for the trigger file. That's it. That's what we will be doing here. If you want, we can even check that. If you see here, let me go to the timer. What is the DAG ID here? Sensor timeout example. And when I trigger this, in this particular path, it will check whether the file has been arrived or not. If you see here, and if you go to the logs, see it will be keep on checking. This particular path doesn't exist at all. This particular file does not exist in my S3. If I go to this particular bucket and if I go to data files, I don't have that particular file, myfile.txt. So it will be keep on checking. That's it. It will be keep on just reschedule. If you see here, the mode has been rescheduled. There will be two modes, poke and reschedule. Let me not confuse you. I will explain about sensors in the next video more clearly, but you just need to understand these two differences. So these are the techniques which I would say we need to be aware of related to the tasks. Okay. In the previous video, we saw about DAGs and tasks as well a little bit. And in this video, we have seen all the techniques related to the tasks in Airflow. Thank you so much for watching. Thank you.